All right, students, this is Mr. Bornheimer. We're going to do lesson 8-6, but this is going to be part B, and this is going to be focusing on this idea known as irrational numbers. Irrational numbers. Okay. Now, if you're sitting here thinking, well, Mr. Bornheimer, goodness gracious, I mean, irrational numbers are great, but I don't even know what rational numbers are. Well, I'm so glad that you asked, because rational numbers can be easily explained. So here's how rational numbers work. There is a whole category. If I draw kind of a box here, there's a whole category of rational numbers. And inside of these rational numbers, you have the family known as the integers. Integers are things like -1, 0, +1, 2, okay? And then you have, so integers are positive, negatives, and 0. Then you have whole numbers. Okay, so these would be things like, let's put the whole numbers in here. Whole numbers would be those things like that do not have decimals. Okay, so 0, 1, 2, 3, 4, 5, etc. And then there are the natural numbers. And the natural numbers are just those like counting numbers, like if you were counting. Okay, so these would be your natural or counting numbers, and you always start those at 1. So like 1, 2, 3, 4, 5, etc., etc., etc. Okay, now, if we are looking at this whole family of rational numbers, there's one underlying principle that's true of all of them. And that rational numbers can be written as fractions, all of them. Whether they positive fractions, negative fractions, improper fractions, it doesn't matter. They can all be written as fractions. Okay, so I'll give you an example of some rational numbers. If you took the value 4.4, you might be thinking, well, that's not a fraction. Well, actually, that's not entirely true. You could always convert 4.4 into a fraction. So you could say, hey, 4.4 is the same thing as 4 and 4/10, which when simplified would be 4 and 2/5. Notice that. And if I really wanted to, I could write this as an improper fraction, and it would be 22/5. Notice here that I was able to eventually write this value as a fraction. All right. Now, you might also say, well, what about repeating numbers? Well, that's a great question. I'm so glad that you asked. So if you have the value 3.3 repeating, okay, it goes on and on and on forever, there's something that's true in mathematics, that all repeating values get put over 9. So this would be the same thing as 3 and 3/9. And if you work this out, you would see that this is 3 and 1/3. And if we really wanted to take it a step further, we could see this is the same thing as the improper fraction, okay, which would be 10/3. Again, notice that I was able to write that repeating decimal as a fraction. So again, all rational numbers can be written as fractions. That's a key idea. So fractions are really important here. And if you want to double check that, you could say, well, hey, 10/3, I just don't believe it. I don't believe that can be a repeating decimal. Well, let's check it out. So 10 divided by 3 equals, hey, 3.3 repeating. Check it out. Okay, so this is how this works. Rational numbers are as follows. If you need a quick cheat list, rational numbers are whole numbers, decimals, whoa, that's crazy sauce, decimals that terminate, so like 4.2, that's it. The 0.2, it ends. So that 0.2 is a terminating decimal. It has an end to it. Repeating decimals. So it could even be things like 3.3333, or it could be, it could be 7.183, 183, 183, 183. It doesn't matter. If there is a pattern, okay, so the 0.3 repeating, or the 0.183, 183, 183, 183 repeating. If there is a pattern, then it is a rational number. Okay? So that's the important part about this. Rational numbers are those values that are whole numbers, decimals that terminate, repeating decimals, and things like integers. Okay, so you've got positive, 0, negative numbers, so long as they also fit into these other categories. So a negative 4.33333 would still be rational because there is a pattern to that decimal. So rational numbers can also be negative. So at this point you may be asking, okay, that's awesome. I love rational numbers. Thanks for the refresher, Mr. Bornheimer. Now, that still doesn't tell me what irrational numbers are. Well, I'm so glad you asked. So irrational numbers. Irrational numbers are characteristic of the fact that they almost always present themselves as a decimal that goes on forever, and this is the big and, okay, because if you stop there, that wouldn't work. These are decimals that go on forever, okay? Irrational numbers are decimals that go on forever, and they have no pattern, okay? Some great examples of irrational numbers include the following. The square root of 2. You might be thinking, well, Mr. Bornheimer, that's not a decimal. But if you take the square root of 2, square root, notice that it's 1.4141235623731. And if I were to keep going, there's nothing here that repeats. There is no pattern, no repetition. And therefore, it cannot be written as a fraction. That makes the square root of 2 irrational. There is a whole slew of other values that are irrational. The square root of 3 is irrational. The square root of 27 is irrational. Pi is irrational. You might be thinking, pi? Yeah. 3.14159 ... It goes on forever with no pattern. It fits that key idea, no pattern. You might be thinking, well, what about the square root of 27? Well, 27 square root, again, no pattern. Well, what about the square root of 3? 3 square root, again, no pattern. Now, if you're asked to do this in an assignment, what's really important here is that if you're given a square root, convert it to a decimal, okay? Because that is how you're going to determine whether it is rational or irrational. You will not be able to determine that if you don't go ahead and convert it to a decimal. So we're going to go ahead and look at a couple of example problems here. And I want you to go along and participate with me here. So example number 1. You're going to try these on your own, and then I want you to go ahead and watch the video as I explain them when you're done. Okay, so here we go. I want you to go ahead and identify these three numbers that I'm about to write as either rational or irrational. So here they are. The square root of 99, the square root of 41, and the square root of 49. Let's go ahead and pause and try these on your own. All right, here we are. So what we want to do is we want to go ahead and figure out whether or not these are rational or irrational. So the key here is whether or not they give us a whole number or something with a pattern or a decimal that has no pattern. So we'll plug in 99. We'll take the square root. That goes on forever, and I don't see any distinguishable pattern. So that is going to be irrational. Now, 41, square root. Again, no discernible pattern, and it goes on and on and on. So again, irrational. It should probably go without saying, but just because it doesn't, you can't see the end of the numbers here in the calculator, does not mean that it doesn't go on forever. If I had a larger calculator, I would see the numbers just would continue to go on and on and on. All right, last but not least, 49, square root. 7, that is a whole number. And so that would make the square root of 49 rational. Okay, so just because it's a square root does not mean that it can't be rational. The value here is 7, and therefore that makes that a rational value. So that's example number 1. Okay, example number 2. Okay, example number 2. I want you to go ahead and give me an example of each of the following. So give me an example of a rational number. Give me an example of a different number, of a integer, of a whole number, and then of a natural number. These, you can't use the same example for all of them. Go ahead and do that right now. Okay, you should have gone ahead and provided examples for each of these. So let's go ahead and take a look at it. Natural numbers are those numbers like 1, 2, 3, 4, 5, 6, etc., etc. These are what we call, they're almost sometimes called the counting numbers. And if you didn't understand this well when we were going over it in the notes, then you should be really working hard at writing down this example or making a note to ask me questions about it later. A whole number is going to be all of those counting numbers, so it includes those counting numbers, but now we're going to add 0 to it. So you have 0 and 1, 2, 3, 4, 5, 6, ... Okay, so the big thing about whole numbers is that we're adding 0 to the mix. Now, integers include whole numbers and natural numbers. Integers, however, are going to also include negative values. So you have 0, 1, 2, 3, 4, 5, 6. But you also then have negative 1, negative 2, negative 3, etc. as well. So it includes there are negatives down here as well. Now, rational numbers are basically all the numbers that include integers, whole numbers, natural numbers, and those values in between that can be written as a fraction. So things like, and I should do this in, so you could have 0, but then you could have 1/2, and then 1, and then something like 1.4 or 1.8, and then 2. And so you've got these fractions and decimals as well. And of course, you can include the negative values as well. So those are all the rational numbers. Okay, so example number 2 is you should have given examples of each of those, etc., etc., etc. Okay, and that is it for this lesson. If you have any questions about this, please reach out. I know there's not as many examples as usual, but this is also the second part of lesson 8-6. So thank you for watching, and if you have any questions, feel free to reach out.